In this video, we're going to look at tangents and normals in the topic of differentiation. So this question says y equals 9 minus 4x minus 8 over x. The point P on C has x coordinate equal to 2. Show that the equation of the tangent to C at the point P is y equals to 1 minus 2x. So what we do for a question like this is we first differentiate the function we have. So we do dy by dx. Now that any constant differentiator will give me 0. Minus 4x differentiated will simply give me minus 4. And don't forget, this is rarely written as y equals 9 minus 4x minus 8x to the power of minus 1. So we get minus 8, bring the power down, minus 1, x to the power minus 2. So dy by dx would be minus 4 plus 8 x to the power minus 2. But because we want to work out the gradient of the tangent at this particular point when x equals to 2, what we want to do is rewrite this in a nice form, which is minus 4 plus 8 over x squared. So it will enable us to do the calculation quite easier. So now we can say when x equals to 2, dy by dx will now be minus 4 plus 8 over 2 squared, which is minus 4 plus 8 over 4. So I'll get minus 4. Well, 8 divided by 4 is simply 2. So that will give me the gradient at the point when x equals 2 of the tangent will be equal to minus 2. So now at A level, what we use for the formula is the following. We say y minus y1 equals to m times x minus x1. Now this is the formula for the equation of a line that we use at A level. Now what we need to do is we need to work out what the y coordinate is. So I can work out what y is when I substitute that back into this equation. So now I need to work out the y coordinate when x equals 2. So I can say y, so when x equals to 2, y is going to be 9, take away 4 times 2, minus 8 over 2. Well, that's 9 minus 8. And then 8 divided by 2 is 4, so I get minus 4. So I get 1 minus 4. So the value of y equals minus 3. So when I write my coordinate down, I get 2 and minus 3. So this is what x1 is, and this is what y1 is. So I say y minus y1, which is minus 3. The gradient we've worked out, which is minus 2. X times x minus 2. So we get y plus 3 equals to minus 2x plus 4. So bringing everything on one side, that gives me the following. So I get y minus 2x plus 4 minus 3. So y equals to minus 2x plus 1. And that's exactly what they wanted. Y equals to 1 minus 2x. Then the question says to work out the normal to C at the point P. So what we do here is we're going to write down the same coordinates. So we've got 2 and minus 3 is x1 and y1. Now mt means the gradient of the tangent. Now we worked out the gradient of the tangent to be minus 2. That's what dy by dx is, the gradient of the tangent. So that's minus 2. When you want to work out the gradient of the normal, which I'm going to use n here, mn means the gradient of the normal, you do -1 divided by the gradient of the tangent. So in our case, it's going to be -1 over -2. So we get the gradient of the normal is simply a half. And now we're still going to use the same formula, y minus y1 equals to m times x minus x1. So we're going to get y minus -3 equals to the new gradient of the normal, which is a half, x minus 2, so that gives me y plus 3 equals to a half x minus 1. So I get y equals to a half x minus 1 minus 3. So I get y equals to a half x minus 4. So that's the equation of the normal, which is perpendicular to the tangent. So for the last part, for the area of the triangle, I've drawn both the equation of the tangent and the equation of the normal. So what we can do is label this first of all and say, well, this is the equation of the normal, which is a half x minus 4. So it cuts the y-axis here at -4. And this is the equation of the tangent line, which we worked out was 1 minus 2x. So where they intersect at this point is the point P, which we worked out already, which has a coordinate of 2 and -3. Now, they tell us clearly in the question that they meet at the following points. If you go back to the question and read it, it says the tangent at P meets the x-axis at A, and the normal meets P at the point B on the x-axis. So we can say that this is A for our tangent line, and this is B for our normal line. So here's the triangle that we need. So what we can say is, well, we know what the height of this is. It's the y distance, which is going to be 3, even though it's -3 going down, but the height of that triangle is still going to be 3. Now what we need to know is what the distance of the base is. So we can do that by setting y equals 0. So if I take my tangent line and say 1 minus 2x equals to 0, then 1 equals to 2x. So x equals to a half. Don't forget the y coordinate here is always going to be 0. Okay, and here and here. So that's what we're going to do. We're going to set both y equations equal to 0. So we now know that the x coordinate of that is a half. Now we need to find the same for b. So don't forget this is now going to be a half and 0 as a coordinate. So for b, it's going to be a half x minus 4 equals to 0. So we can say a half x equals 4, times in both sides by 2, x equals 8. So the coordinate here will be 8 and 0. But this x equals 8 here. So now I've got x equals 8 for b, and I've got x equals to a half for a. So now what we can do, the distance of the base of this triangle is going to be 8 minus a half, which is 7.5. As an improper fraction, that's 15 over 2. So now I can work out the area of my triangle. So we know what the area of a triangle is. The area of a triangle is base times height divided by 2. So I can write a half times the base is 15 over 2. And the height was 3. So that will give me 45 over 4 units squared.